Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In today's lecture, we are going to cover up hypothesis test. It could be a scenario of binomial, it could be a scenario of Poisson, or it could be normal approximation to binomial or normal approximation to Poisson. Now, first of all, from the topical book, exercise B, let's do some questions related to binomial. Now, some of the questions will be the one that you might have seen earlier, so we will just skim over that. Now, first of all, over here, let's read this question. And the question says, before attending a basketball course, a player found that 60% of his shots made a score. Now, the very first thing about binomial is that when we are talking about hypothesis test for a binomial distribution, we need to focus on the probability of success. We need to focus on the number of trials. We need to focus on the sample value. We have to keep in mind that the sample value by default is inclusive. And then based upon the direction of the alternative hypothesis, we have to calculate the probability. And then we have to apply the p-value test. So that is what it's all about. So now let me read it further. After attending the course, the player claimed that he had improved. Hypothesis is all about accepting and rejecting claims. Whether you accept a claim, whether you reject a claim, that's what it's all about. In the next game, he tried 12 shots and scored in 10 of them. Assuming the shots to be independent, test this claim at the 10% significance level. Now, first of all, let me draw those 4 boxes. So that is the first box, and I need it to be filled with color. So that is the first box. Then there is the second box. Then there is the third box, and then there is the fourth one. Okay, so now let me get started. First of all, I need to write down that this is binomial probability distribution. And based upon that, I'll write x, the variable x follows a binomial distribution. What is the number of trials? That is 12. What is the probability of success? That is 0.60. So whatever you find out, just highlight that. We have used 60%. We have used 12. And now what is this 10? This 10 is the sample value, which by default is inclusive. So sample value is 10, and make a habit of writing over here that it's inclusive. And then let's jot down the H0, the null hypothesis, the H1, the alternative hypothesis. In binomial, it's based upon probability of success. So probability of success is this value, that is 0.60. And improvement probability is greater than 0.60. And what is the significance level about? The significance level is 10% level of significance. So let me also highlight whatever else I have used again. So I have used 60% for H0 and H1. I have used the word improve for upper tail test, and I have used 10% significance level. So technically, I have done everything over here. Now, since the alternative hypothesis is in the greater direction, so based upon this value, I'll do the calculation. Probability x is greater than or equal to 10, which is 12C10. I'll fill up the brackets. That's the way I write it. 12C11, and then 2 brackets, 1 for success, 1 for failure. Similarly, 12C12, success and failure. So I write the success at the end. So 0.60 goes over here with a power of 10. 0.6 goes over here with a power of 11. 0.6 goes over here with a power of 12. What is left? Probability of failure. That is 0.4, that is 0.4, that is 0.4. The difference between 12 and 10 is 2, and 12 and 11 is 1. 12 and 12 is 0. Again, re-emphasizing the very common fact that the sum of the powers should always add up to n, which is 12 in this case. Now, once you have used a calculator, it's your choice whether you want to show the 3 answers in decimals separately and then add it up, or just show this much working, use a calculator properly, and then give this answer over here. So let me take a sneak preview of the next page. because I have done this earlier, and this comes out to be 8.34. So technically, this is 0.0834. That is 3 significant figure. Well, in the case of this p-value, significance does not make a lot of difference. So it's not that much of an issue. But since everything is done to 3SF, so therefore work in 3SF. Final answer. And now convert it into percentages. So therefore multiply by 100, that is 8.34%. Now it's a one-tail test. We are finally moving towards the conclusion. So we will write that for one-tail test, the probability value in percentage, if it's lesser than significance level, which is already in percentage, then the conclusion is reject H naught. This is the significance level. This is the p-value. 8.34% is lesser than 10%. Therefore, reject H naught. Therefore, accept H1. What is H1? H1 is right over here. This was based upon improved. This was based upon the claim of the player. So we will say there is sufficient evidence, and do mention the significance level also. There is sufficient evidence at 10% significance level that the player's claim is true. Or if there is sufficient evidence at the 10% level to accept the player's claim, which is H1. So that is how you have to write it. Now let's look at the marks. It's for 5 marks. So for 5 marks, first of all, I will be giving 1 mark over here. I'll be giving 2 marks over here. I'll be giving 1 mark based upon this inequality, and technically 1 mark over here. Or maybe there is a possibility that 1 mark for the whole thing and 1 mark for over here. So now let's look at, this is last year's, before that working. They have not that much emphasized on this. So it's H naught, H1. They did not bother writing binomial. I think we should. X is greater than or equal to 10, the probability, and I think the conclusion is missing, or maybe I have forgotten to cut paste this. So that's how this question is done. So now another question that's waiting for you. Let me pause the recording so that you people can try this out. So now let's look at this question, and let me start underlining. That is one of the recipe of success, that you should underline the relevant details. Johan claims that a certain 6-sided die is biased so that it shows a 6 less often than it would if the die were fair. That means a bias could have been greater than 1/6 or lesser than 1/6. So they have clarified. And in any case, if they did not clarify, that means the hypothesis alternative would have been not equal to. So now it says, in order to test this claim, that is what hypothesis test is all about. The die is thrown 25 times and it shows a 6 on only 2 throws. That is the sample value. Test at the 10% significance level whether Johan's claim is justified. Let me first make the boxes, or without the boxes, let me write step 1. Another way of writing, if you don't want to make the boxes. The first thing, it's binomial. X follows binomial distribution 25, 1/6. That's the probability of success. And then the sample value, that he obtained a 6 only on 2 throws, which that by default is inclusive. So let me highlight this. First of all, this thing is there. That is less often. This I'll use right now. 25 times, that's over here. 1/6, 6-sided die, that is this 1/6. And this 2 is over here. Now, step number 2. That is H naught. P is equals to 1/6. H1, P is lesser than 1/6. And it's at the 10% significance level. So now again, we are using this thing, which is this 10% that's used. probability of 6 is used, and less often that is used over here. And this thing is used, 1/6. Step number 3. So now step number 3, this is about the working. Probability X is lesser than or equal to 2. We would start with the sample value. We will go in the lower tail direction. So this is 25C2, and then 25C1, and then 25C0. Probability of success, that is 1/6 power 2, 1/6 power 1, 1/6 power 0. Probability of failure 5/6, 5/6, 5/6 power 23, 24, and 25. And then we would add up all the probabilities, and I think it comes out to be 18.9%. Okay, so now the step 4, that is the conclusion part. That is compare 18.9% with the half of, no, it's not a two-tail test, my bad, with 10% significance level. So this is not true. Therefore, we will say there is insufficient evidence to accept claim made by Johan. And before that, of course, you can write, if you want to, that do not reject H0. In other words, accept H0. That means we have insufficient evidence to accept the alternative claim which is made by this person, Johan. So that's how this particular question is done. That's the mark scheme. Okay, so now let's move to Poisson distribution. Why don't you people try this particular question out? Let me pause the recording. So now let's look at this question. The question says, the number of workers X absent from a factory on a particular day has the distribution binomial 80, 0.01. Now it says, originally the question is binomial. Explain why is it appropriate to use a Poisson distribution as an approximating distribution for X. So what is the condition? The condition is simple. N has to be greater than or equal to 50. And at the same time, simultaneously, NP should be lesser than 5. So 80 into 0.01, that will become 0.8. So NP over here is 0.8. N, you can see for yourself, that is 80. Both conditions are fulfilled. Therefore, you can convert it into Poisson. So now it will become X follows a Poisson distribution with 0.8. That is for a particular day. The next part, it says use the Poisson to find the probability. So this is about probability. It's not about hypothesis test as such, that the number of workers absent during the 12 randomly chosen days is more than 6 and less than more than 2 and less than 6. So in other words, 12 into 0.8, that comes out to be 9.6. That is now the lambda for this thing. And more than 2 means greater than 2. Lesser than 6 means less than 6. So basically, this is 3, 4, 5. So probability X lies between 3, 4, and 5 inclusive. That is what you have to calculate. And then it further says, following changes in working condition, the management wishes to test whether the mean number of workers absent per day has decreased. It's a lower tail test. During the 10 randomly chosen days, there were a total of 2 workers absent. Use the Poisson distribution to carry out the test at the 2% significance level. So I already have the working. Let's just use this working this time. So first of all, what you need to do is that H0, H1, and the significance level, that is 2.5%. The first box, that is stating that X follows a Poisson distribution with 8. How did you get 8? That is 0.8 into 10. That's how you get 8. And this thing, 2, that is the sample value. It's inclusive by default. And then the third step, that is this one. We calculate probability X is lesser than or equal to 2 according to the Poisson formula, and we get 1.38%. And the last step, that is about this one. that is the comparison, that is the significance level, is the probability value in percentage lesser than the significance level? The answer is yes. So it's fulfilling this thing. So you would say reject H0, accept H1. There is sufficient evidence at the 2% level that suggest that what is this? That the number of absences has decreased. Following the change in working condition, the number of absences has decreased. I think that is the symbol that I've used over here. Okay, so now it's about normal approximation. Keep in mind, as I stated yesterday, that sampling distribution has nothing to do with hypothesis tests related to normal approximation to binomial, related to normal approximation to Poisson. It's just the old school stuff. That is, you have to calculate expectation, you have to calculate variance, you have to fulfill the condition, and then it would become normal. And don't forget continuity correction. When we are talking about Poisson, a normal approximation to Poisson, so we know that expectation of x is lambda, so is the variance of x. And what's the condition? If lambda is greater than 15, then x follows a normal distribution, lambda comma lambda. And don't forget continuity correction. This is not a sampling distribution concept. That is one thing. So now this is the question that we did yesterday in class. Let me just go through it quickly, and then we will pick a new one. A new cold relief drug is tested for effectiveness. On 150 volunteers, 124 of them found the drug beneficial. Manufacturers believe that more than 75% of the people will find drug beneficial. Test the manufacturers' belief at the 2.5% significance level. So now, first of all, you have N, you have P. You should also calculate NP, you should calculate NQ, that is for justification. Both values are greater than 5. So this one is greater than 5. This one is greater than 5. And then you have to use NP and NPQ. That will go on the inside over here. Sample value is 124. Alternative hypothesis is P is greater than 0.75, 2.5%. Now, one other thing is that you should write this inequality, and then you should do the continuity correction and then calculate the Z value. So now x is greater than or equal to 124. Why? Because it's an upper tail test. Greater than or equal to 124 becomes greater than or equal to 123.5. Then find the Z value. Then compare the Z value whether it lies in the critical region. For 2.5%, the Z value, the boundary condition is 1.96, 2.074 lies inside the critical region. Therefore, there is sufficient evidence at the 2.5% significance level to suggest, to accept manufacturer's claim. Okay, another question, binomial question, but this time it's a two-tailed test. Let me underline it again. It says a jar contains a large number of colored beads, some of which are red. And then it says a random sample of 80 of these beads is selected and 19 are found to be red. Test at the 10% significance level whether 10% of the beads in the jar are red. So now this is a two-tailed test because we are not talking about increase, we are not talking about decrease. Therefore, it's a two-tailed test. So let me first do the preliminary working over here. X follows a binomial distribution. 80, 30% is your probability of success. Let me only calculate NP, which is 80 into 0.3, which comes out to be 24. I just want to emphasize the fact, what is the direction in which we will do the calculation? Now, this is the sample value. So 19 is the sample value. And this sample value is lesser than the mean. So therefore, you should go in the lower tail direction. So now you would do this thing. Probability X is lesser than or equal to 19. You should draw a number line. Write 19 over here. Write 18.5 over here. Write 19.5 over here. Two options are there for the number line. Since by default, sample value is always inclusive. So over here, this is the correct option. So now you will write probability X is lesser than or equal to 19.5, and then you will get the Z value, and then you would do the comparison. So I wanted to focus on this thing. One thing, that was the continuity correction. The next thing, why are we going lower tail? Although the H1 SP is not equal to 0.3, H0 P is equal to 0.3. We are going lower tail because the sample value is lesser than expected value. Expected value is the mean. If instead of 19, we would have 29, we would focus on the upper tail. That is the simple rule. So now let's look at the working. First of all, NP 24, NQ 56. This is used for justification. NP 24, NPQ 16.8. This is mean, this is variance. This is mean, this is variance. 19, sample value, lower tail. First of all, H1 is two tail, significance level. Now this sample value is lesser than mean, focus on lower tail, therefore calculate probability in this direction. 19.5, Z value becomes negative 1.097. 10% significance value splits into two, 5% on the lower tail, 5% on the upper tail. Z value is 1.645, negative 1.645. This value lies outside of the critical region. What is the conclusion? Do not reject H0, accept H0. There is insufficient evidence and make a habit of writing at 10% significance level. And what are we talking about? Whether the 30% of the beads in the jar are red. So to accept that 30% of the beads in the jar are not red, because the original thing, the default is 30% are red. Alternative, no, they are not 30%. They could be greater or lesser. So we cannot accept the claim that they are different from 30%. So we have to settle down on this thing. So let's say accept H0, 30% of the beads are red, and you have to write that this is insufficient evidence at 10% significance level. Therefore, we have to accept that 30% of the beads in the jar are red. So that completes the concept of binomial, Poisson, and two normal approximation. And this is all about hypothesis. Stay tuned for more content.